This is part 2 of the final review. We're picking up with number 15. And this is where we do a lot of factoring. Almost everything in the next few problems will be factor it and cancel it. Okay, so my directions say to simplify this. And the only way I can simplify it is by factoring it and canceling whatever is the same. So the first thing I have to do is factor the numerator. So I'm looking for what multiplies to give me 14 and adds to give me -5. The only thing I can think of is 7 and 2. So if I do this as x minus 7 and x plus 2. Okay, the denominator is a little bit more difficult because it's got that number, that leading coefficient. So I'm kind of going to do it off to the side and then bring it back over. So remember when we did this, we took the 2 and we multiply it to the end. So we make this be x squared minus x minus 20. Now from this format I can say what multiplies to give me 20 and adds to give me -1. So I can say 4 and 5 are going to multiply to give me 20. And if I have -5 and +4, then that'll work for us to give -1. The only problem with this is that I still have to divide by 2. So divide this by 2. And divide this by 2 because remember we started out by multiplying by 2. So 5 over 2 does not simplify, so I'm going to squeeze the 2 in with the x and make this be 2x minus 5. But 4 divided by 2 does reduce, and it just reduces to x plus 2. So now I've taken this over to the side and factored it. Now I can plug this back in. So my factors are 2x minus 5 and x plus 2. And I'm looking to see what cancels. And I have an x plus 2 in the numerator that cancels with an x plus 2 in the denominator. So once I've canceled, what's left is going to be my solution. So x minus 7 over 2x minus 5. That's the simplified version of what we started with. Okay, for number 16, we have the same situation. We're still simplifying. This one's a tiny bit easier because the denominator is going to be a little bit easier to factor than what we had before. Alright, so we're going to factor this. What multiplies to give me 12 and adds to give me +1. So I'm going to use 4 and 3 and make 4 be positive and 3 be negative so that they add up to be +1. And then for x squared minus 3x, it's only 2 terms and they're not both perfect squares, so I'm going to see what do they have in common that I could take out. X squared and 3x both have an x that I could take out. So I'm going to put the x outside the parentheses. And since I took the x out, I'm basically just dividing by x here. And that's going to leave me with x minus 3. For the ones that you're going to simplify like this, keep in mind that the goal is for something to cancel. So if you don't see something cancel, you might want to double check and make sure you didn't mess up your factoring. So I see x minus 3 top and bottom. That's going to cancel. And that leaves us with a simplified version of x plus 4 over x. Number 17. We are still simplifying, but this time we have a multiplication problem. Multiplication is the same thing as what we just did, it's just more of it. We just have to do a lot more factoring. Okay, so let's start right here. 2x minus 10 is two terms, so we're going to see what do they have in common, and they're both divisible by 2. So I'm going to write this as 2 parentheses. When I take the 2 out, that's going to leave me with x minus 5. When I look at x minus 4, nothing is squared and there's nothing in common, so there's nothing that can be simplified with x minus 4. It's already simplified. For x squared plus 5x plus 4, I need two numbers that multiply to give me 4 and add to give me 5. So I'm going to use x plus 4 and x plus 1 because that would add up to 5. And then in the denominator here, I need two numbers that multiply to give me 5 and add to give me negative 4. And not very much multiplies to give you 5. You only have two options. So I'm going to use x minus 5 and x plus 1 because negative 5 and positive 1 would add up to negative 4. Now when I can cancel anything from this whole numerator with anything in the whole denominator. It's basically just one giant problem. So I see x minus 5 in the numerator, x minus 5 in the denominator. I see x plus 1 in the numerator, x plus 1 in the denominator. X plus 4 and x minus 4 are not the same, so I have to leave that. So what I'm left with is this 2 times x plus 4 divided by x minus 4. So 2 parentheses x plus 4 divided by x minus 4. Alright, number 18. This is a division problem, but the process is not really that different. The only problem we have with division, and I'm going to go ahead and start out doing that first here. If I have division, I have to change it to multiplication and flip the second fraction. So x squared plus 2x minus 3 is now in the numerator. 2x plus 10 is now in my denominator. So keep, change, flip, change the division problem into a multiplication problem, and then factor everything. So, starting with the top left corner, x squared minus 25, these are both perfect squares. So it's going to become x plus 5 times x minus 5. For this denominator right here, I'm going to multiply, what numbers multiply to give me 5 and add to give me negative 6. So I have to use 5 and 1, so I'm going to use negative 5, x minus 5, and x minus 1. For x squared plus 2x minus 3, I need what multiplies to give me 3 and adds to give me 2. So 3 has to be 3 times 1, so I'll do plus 3 minus 1. And then for 2x plus 10, it's just two terms, but they're not perfect squares, so I'm going to see what they have in common. 2x and 10 are both divisible by 2. I'm going to put 2 on the outside of the parentheses, and if I divide by 2, I'm left with x plus 5. Okay, so we started with keep, change, flip, then we factored everything. Now we're right back to where we were because anything in the whole numerator can cancel with anything in the whole denominator. So let's see, x plus 5 cancels, x minus 5 cancels, x minus 1 cancels, And the only things we're left with are x plus 3 in the numerator and 2 in the denominator. Number 19. This is also a division problem. So the first thing I'm going to do is keep, change, flip. So I'm going to keep the first fraction, change this to multiplication, and flip the second fraction. Okay, so keep, change, flip, and then factor. So I'm going to start with the top left numerator, and I'm going to look for what multiplies to give me 27 and adds to give me negative 6. So 27 is 3 times 9, so I'm going to do x minus 9 and x plus 3. For this denominator, I have two terms, but they're not both perfect squares, so instead I have to look and see what do they have in common. They're both divisible by 2, so I'm going to take a 2 out. And they both have at least one x, so I'm going to take an x out, and then I'm going to put my parentheses. So when I divide by 2x, what I'm left with here is going to be x plus 1. On the right side, x squared is already a factored term. There's nothing to factor there. And then for x squared minus 4x plus 45, I need to see what multiplies to give me 45 and adds to give me 14. And I think we've done this one already once. So it's x minus 9 and x minus 5. Keep, change, flip, then factor it all out. Then remember, anything in the numerator cancels with anything in the denominator. And I see x minus 9 cancels. And it might seem like that's the only thing, but I see one more thing that can cancel. Remember that x squared is the same thing as x times x. So if we change it to x times x, do you see there's an x down here that will cancel with an x up here? So I'm going to cancel one of those. So when I check to see what's left, then I see x plus 3 is left. One of those x's is still there. The 2 down here is still there. The x plus 1 is still there, and the x minus 5 is still there. So I have x plus 3 times x divided by 2 times x plus 1 times x minus 5. Number 20. Alright, we've done simplifying, we've done multiplying, we've done division, and now we're going to do subtraction and addition. When you add and subtract with rational equations, you have to get a common denominator. Well, the first thing you have to do is make sure that your denominators as they are factored, and x squared minus 16 is not factored. So I'm going to rewrite the first one, 2 over x plus 4, and then I have x squared plus 4 in the numerator, but the denominator, x squared minus 16, actually factors into x plus 4 and x minus 4. So to get a common denominator here, then I'm going to look to see what do they have in common, and both of these have x plus 4. So I'm going to keep that x plus 4 in both cases, and this is the denominator we're talking about. But then I also need an x minus 4, so I've got to put x minus 4 in both places. Then I'm going to do a little comparison. My previous problem up here did not have x plus 4 in the denominator, so I had to multiply it by x minus 4. And if I multiply the denominator by x minus 4, I also have to multiply the numerator by x minus 4. So that leaves me with 2x minus 8, because I'm distributing the 2 into the x minus 4. Now on the right side, x plus 4 and x minus 4 was already there, so I don't have to change the numerator either. So now that they both have the same denominator, I'm going to try to squeeze this in over here. The denominator is x plus 4, x minus 4. But now that they have the same denominator, I can add or subtract. If I'm subtracting, keep in mind that I'm subtracting each of these things. So it's 2x minus 8 minus x squared minus 4. So 2x minus 8 minus x squared minus 4. And if I combine my like terms, I'm going to have negative x squared plus 2x, and then I have minus 8 and minus 4, which would be minus 12. And that's the big long solution. Number 21, we're still adding rational expressions. But in this case, my denominators don't have anything that's in common. X plus 2 is already a factor. X plus 5 is already a factor, so I don't have to simplify them at all. But I need to have both of them. So x plus 2 has to be in both denominators. And x plus 5 has to be in both denominators. So if I do that, then I'm going to make a comparison here. In my old fraction, I had 5 over x plus 2, and I have to put an x plus 5 in the denominator, which means I have to put an x plus 5 in the numerator. So now my new numerator is going to be 5x plus 25. On the right side, my old fraction had x plus 5 in the denominator, but it was missing x plus 2. So I have to put the x plus 2 there. And I also have to put the x plus 2 in my numerator. So then my new numerator on the right side is going to be 8x plus 16, because I'm distributing my 8. So once they have the same denominator, all I have to do is add up the like terms in the numerator. So x plus 2 times x plus 5, that's my denominator. That's not going to change. But in my numerator, I'm going to have 5x plus 8x, which is 13x. And I'm going to have 25 plus 16, which is 41. And that's my solution. For number 22, we are solving for x. That means we have to get x by itself. And the nice thing about number 22 is that we have one fraction equal to one fraction, which means we can cross multiply. So if I take 6 times x plus 1, it's going to be equal to 9 times x minus 1. So I'm just multiplying numerator times denominator and denominator times numerator. Flip-flop. Okay, so on my left side I have 6x plus 6 And on the right side, I'm going to have 9x minus 9. My goal here is to get x by itself. So I'm going to subtract 6x from both sides so that the x's will be together. So then I have 6 equals 3x minus 9. And I'm just going to finish solving this and have my answer. So add 9 to both sides, divide by 3 on both sides, and you're going to get a solution of x equals 5. Alright, so last one for this video is going to be number 23. We have 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. And we need to get a common denominator, but x squared minus 9 is not factored because it's the difference of two squares. So the first thing I have to do is make sure it's factored. So I'm going to have 6 over x minus 3 equals 8x squared over x squared minus 9 factors into x plus 3 and x minus 3. And then 4x over x plus 3, that doesn't have to change because x plus 3 is already factored. So now when I look for my common denominator, I can see that this problem right here has x plus 3 and x minus 3. So I'm going to look at the other two and see what they're missing. So if I look at this first one, I have the x minus 3, but I don't have the x plus 3. So I have to put x plus 3 in the bottom, and I have to multiply by x plus 3 in the top. Then on the far right fraction, I have the x plus 3, but I don't have the x minus 3. So I have to multiply by x minus 3 in the bottom and in the top. So this is going to totally change my problem. So now I have 6x plus 18 equals 8x squared minus 4x times x minus 3. And I have totally dropped the denominator. The nice thing about an equation, which means you have the equal sign, is that once you have a common denominator, you actually can drop the denominator. So now the only thing we're having to do is just solve this problem. And it's not quite so simple and straightforward because we do have an x squared term, but other than that, we can do this okay. So we're going to have 6x plus 18 equals 8x squared, and then I'm going to distribute the negative 4x. So this would be negative 4x squared, and when I multiply negative 4x times negative 3, I'm going to get positive 12x. So I'm just going to kind of add and subtract my like terms as I go. 8x squared and 4x squared right here, this becomes just 4x squared. But plus 12x. If I go ahead and subtract 6x from both sides, and I go ahead and subtract 18 from both sides, then on the left side I have 0, which is what I want because I'm going to have to factor this. So if I just kind of combine this a little bit, I'm going to have 4x squared plus 6x minus 18, bless you, equals 0. And then I want to factor this and solve it, which is kind of a pain. So let's see, I'm going to go to the next slide. Okay, so we have 0 equals 4x squared plus 6x minus 18. And one little trick that I kind of like to do, if you notice 4 and 6 and 18 are all divisible by 2. So if we divide everything by 2, we get 0 divided by 2 is 0. 4 divided by 2 is 2x squared. 6 divided by 2 is 3x. 18 divided by 2 is 9. Now it didn't do a whole lot, but it did make a little bit simpler problem. So since I have x squared and x in the same problem, I have to factor this. And since I have a 2 in the front as my leading coefficient, I have to deal with that also. So I'm going to start off by multiplying 2 to the end, which will change my problem to be x squared plus 3x minus 18. And then I'm going to look for two numbers that multiply to give me 18 and add to give me 3. So I'm going to have x plus 6 and x minus 3, because that still multiplies to give you 18. And then I have to divide by 2, because I multiplied by 2 at the beginning, so now I have to divide by 2. So I have x plus 3, and I have x minus 3 halves. Now I didn't squeeze the 2 over, because since it's equal to 0, all I have to do is write the opposite to get the answer. So remember, anything in parentheses, the opposite's going to be the answer. So the opposite of 3 is negative 3, that's one solution. And the opposite of minus 3 halves is positive 3 halves. So that's my other solution.